The first question. The graph shows the variation with time of the velocity of an object. Arrow bars for velocity are included. What is the percentage uncertainty for the velocity at time t is 4 seconds? So we should consider a point when t is 4. And we can see that value is 8, so velocity is 8 meters per second, and this length is the absolute uncertainty in velocity, delta v, is 1 from the graph again. And delta v over v, it's the relative uncertainty, and if you multiply by 100, you get the percentage uncertainty. Delta v over v, it's relative or fractional. If you multiply by 100%, you just convert it into percent, and it's called the percentage uncertainty, and it becomes 1 over 8 times 100%. It's 12.5%, and options are 20, 10, 8, 5, and we can see that it's approximately 10% to one significant figure, and hence it's B, 10%, plus minus 10%. The second question. A toy car of mass 2 kilograms is at rest on a horizontal surface. A force of 30 newtons is applied to the car. At time t is 0, frictional forces of 10 newtons act on the car throughout its motion. What is the speed of the car at 2 seconds? So, driving or the thrust force of 30 newtons, frictional of 10. So we can see that resultant and its net force is 20 newtons, and we know that F is ma, so acceleration is 20 over 2, it's 10 meters per second. And v is what, u plus at, it's 0 plus 10 times 2 seconds, it's 20 meters per second, it's b. 3. A stone is thrown vertically up from the top of a cliff with velocity v at t is 0. Notice that usually we denote it as u, the initial speed or velocity, but here it's v, but in general it doesn't matter, but don't get confused when you consider v is u plus at. Here this u it's v, and it's some another final velocity. And what do we need? Air resistance is negligible. What is the variation with time of the velocity of the stone until it hits the ground? So we need velocity time graph. And options are like this. It's vt, it's a, it's b, it's c, it's curve c, and d, something like this. So let y be up, hence since the initial velocity is upwards, so initially v is positive, and hence we can see that for every option the initial value is positive. It's because we choose y to be up. And you can see that at some point it stops at the highest point, so there must be a point v0. And also we know that v is what? It means final, it's initial, it's v here, plus at, acceleration, its acceleration due to gravity is downward, so it's in opposite direction to y, so it's minus gt. Oh, you should understand since it accelerates initially, it's minus, it opposes motion. And if it's y and t it's x, you can see it's of the form y is mx plus c, and such a graph, it's what is a straight line, so it is expected that it should be a straight line, not a curve. So definitely it's not c. And since gradient is negative, it's decreasing line. And why is it decreasing line? Because it decelerates and at some point it stops. So this interval, it's here, and then it becomes accelerated. So initially it decelerates and stops, and then it accelerates, velocity increases or speed increases, but in opposite direction. This, or just it's a straight line. Gradient is the y-intercept, it's v, and gradient is negative, so it's decreasing line, so it's a. And it implies that it's in direction opposite to y direction, because when it moves here, v is downwards, so it's negative. Negative doesn't imply deceleration, stopping. It accelerates, but in opposite direction. Okay, there are two balls. One is just dropped, and another is projected horizontally with some initial speed. So it moves like this. And there are four options, and which statement is true? Air resistance is negligible. Which statement is true? The velocity on impact with the ground is the same for both. So let's consider velocity. So we know that v is u plus at, g is downwards, let y be upwards. So for vertical component, both of them have zero initial vertical component of velocity, so it's 0 plus gt. And for horizontal component, for one it's 0. For what object number 2, since acceleration is downwards, horizontal component of acceleration is 0, so horizontal component of velocity is constant. And if we consider displacement s, it's what ut plus at squared over 2, and for vertical displacement it's what, again 0 because u is 0, and gt squared over 2. But there is same height, hence same vertical displacement, so time of travel is the same. Time is same to travel. But when one hits the ground, it has some vertical component of velocity, which is all velocity, because there is no horizontal, so it's actually resultant velocity. But for object number 2, there is the same vertical component, but there is horizontal component, which is u, and the resultant velocity is the sum of two vectors, parallelogram rule, and it's this vector. And definitely, since it's hypotenuse, if you consider right angle triangle, you can see that definitely the resultant velocity is greater than vy. So the velocity on impact with the ground is the same for both. Velocity it's a vector. Definitely it's not the same, because the resultant velocity is this vector, and the resultant velocity for this object is this vector. They are different, so velocities are different. B. The time taken to hit the ground is greater for ball 2. No, time is the same. C. The speed on impact with the ground is the same for both. No, because speed is magnitude of the velocity, so magnitude of this vector and magnitude of this vector magnitudes are different, so speeds are different. And D. The velocity on impact with the ground is greater for ball 2. Yes, it's correct, because velocity it's this length of this vector is greater, so it's d. 5. A variable force with maximum F max is applied to an object over time interval capital T. The object has a mass m and is initially at rest. What is the speed over the object at time capital T? So it is given force time graph, and we know that if we meet force time graph and velocities, it's about what? It's about that impulse is equal to change in momentum. And when force is constant, we just multiply, but when it's a variable impulse, it's area, and we can see it's triangle, so impulse it's area is half times base times height, F max times capital T, because it's distance time interval is capital T. Be aware when you consider coordinate and time interval, and is equal to change in momentum. What is change in momentum? It's mv after minus mv before. Since it's initially at rest, it's 0, and we need final speed, so it's v. V is required, so we can see it's F max T over 2m. It's A. 6. The angle theta between a ramp and a horizontal surface slowly increases from 0. An object on the ramp does not slide as theta increases. The frictional force on the object is constant, negligible, proportional to cosine, proportional to sine of theta. An object on the ramp, theta, which increases. Let's consider forces. mg, normal reaction, frictional, and frictional is not negligible. Why? Because without, or when frictional is 0, we can see that there is a component of mg along the ramp, hence there is net force along the ramp, and if there is net force, there must be acceleration. It means it would go down. But if there is some frictional force which balances this component of mg along the ramp, hence it doesn't move. And what is component of mg? It's projection. This projection, you can see that it's a right angle triangle. It's hypotenuse, it looks like this. Hypotenuse is mg, from geometry theta is here, and component along the ramp, sorry, it's sine. It's always sine. You may just remember that for such type of problems it's always sine. And component on, if we consider it to be x-axis, it's y-axis, component on y-axis, it's cosine. So here F frictional is balanced by mg sine theta, and when theta increases, frictional force, definitely frictional force not constant, because it also increases. Negligible, not negligible, because it would go down if force is negligible. Proportional to cosine, no. Proportional to sine, yes, okay, we can see sine, so it's proportional to sine. It's D. 7. An object of mass m is accelerated vertically upwards by a motor. At a constant acceleration, the object is initially at rest and reaches a vertical speed of 4 meters per second in 2 seconds. What is the average power output of the motor? So, average power, it's total work done or total energy obtained by the object. It's work or energy divided by time. It's the first way how to calculate it. And when object is moving up and it gains speed of 4, so it gains kinetic energy, but also this motor must do work against gravitational attraction, so it also gains gravitational potential energy mgh, and it becomes 2, it's 2 seconds, time interval is 2 seconds. Kinetic energy is mv squared over 2, m is capital M here, v is 4 here, over 2 plus mg. What about height? We know what v final is u plus at, and let's consider forces on the object. It's mg, some driving force or thrust force from the motor, and the object has some acceleration, and the situation looks like this: F driving minus mg is ma, and this a is here, and 4 is 0 plus a times 2, and we can see that acceleration is 2, and we need height, so we consider displacement. It's ut plus at squared over 2, it's 0, so it becomes 2 times 2 squared over 2, it's 4, so h is 4, and g is approximately 10. So it becomes what? 16 over 2, 8 plus 40, 48 over 2 is 24 m. Or if we consider forces, we know that power is F times V. But if you consider, if force is constant and V is constant, power at any moment of time will be equal to the power average power. But you can use this formula if you need power at any moment of time. Power at any moment of time, it's force at any moment of time because it can change, and the velocity at the same moment of time. But if we consider average, we can do the same, we can use the same formula, but force must be average, and V also must be average. Force is constant here, and force is, notice that force is not ma, because ma is the resultant force on the object, but we consider motor, so it's power provided by a force. We should consider force provided by the motor. It's this F, which is so motor provides what? Resultant acceleration and also force against gravity. So it's what? It's ma, which is what? A is 2, so it's 2 m plus what? mg, it's 10 m, so it's 12 m, and v, but v changes, and it changes uniformly, constant acceleration. So average, it just divided by 2, so it's 4, or v changes from 0 to 4, so average, it becomes just divided by 2, so 4 over 2, and you can see it's 24 m. So it's B, not C, not 32 m, because it is given that it's C in mark scheme. It's not correct. The correct answer is B. 8. An object is released from rest at X and slides to Y. X, Y, and height is 10 meters. The vertical distance between x and y is 10 meters. During the motion, 20% of the object's initial gravitational potential energy is lost. Lost, it means 80% remains. And gravitational potential, it's what? It's mgh. mg times 10 and 0.8 becomes what? Kinetic at ymv squared over 2. And question is, what is the speed of the object at y? So we need v. M cancels and it becomes what? 16g and square root. So just for root g. For root g it's c. Yes, it's correct. 9. The temperature of a gas increases from 100 to 330 kelvins. What is the change in temperature of the gas in degrees Celsius? We know that delta T is the same for both Celsius and Kelvin, and we know that if you meet delta T, you may use Celsius or Kelvin, it doesn't matter. But if you meet a formula where there is just T, there must be Kelvins only, because Kelvin is SI unit. So it changes the same and changes to 130 is B. Oops, it's 9. B. Delta T is 230 kelvins and the same degrees Celsius. 10. What is the internal energy of an ideal gas? The sum of the intermolecular potential energies of the molecules. We know that the assumption to be an ideal is that potential is 0. And internal or total energy is kinetic plus potential. So for ideal, total energy is equal to the total random kinetic energy of the particles. So A is not correct. Energy required to raise temperature by 1. No, the sum of the kinetic energy of the molecules. Yes, it's correct. (11) A vessel contains a mass x of helium and mass of 2x of oxygen. Molar mass of helium 4 grams per mole, and oxygen 32 grams per mole. What is the ratio number of helium atoms, number of oxygen molecules? And actually be aware, because here it's oxygen, it's contains some molecules, here not atoms. In general we can say particles, so we just consider particles. So number of helium atoms and number of oxygen molecules. Oxygen, so, and how to relate mass, molar mass, and the number of particles. Number of particles, it's mass divided by molar mass, and you may trace units, mass in grams divided by grams per mole. Mole becomes in numerator, so and you can see that you get number of moles, and if multiplied by Avogadro constant says us number of particles in 1 mole of a substance. Anyway, Avogadro constant cancels, so it becomes m mass of helium divided by molar mass of helium, and mass of oxygen divided by molar mass of oxygen, and we get mass of helium, it's what, x over 2x, 32, and molar mass of helium in the denominator is 4, and molar mass of oxygen is 32 in the numerator, and it's 4. It's C. A balloon of volume V contains 10 milligrams of an ideal gas at pressure P. V 10 milligrams, pressure P. An additional mass of the gas is added without changing the temperature constant. This change causes the volume to increase to 2V and the pressure of 3P, which is the mass of the gas added, delta M required. So general formula is PV is, and number of moles are T. And notice that if mass of gas is constant, and if you do something with gas, you may use PV over T is constant. But here it's not true because it's not constant. In general, and actually for any problem, you should use both simultaneous equations initially and then this formula. So initially P1 V1 and 1 are T1, and since we need mass, let's rewrite it as number of moles, it's mass over molar mass. So initially it's what? PV is 10 over capital M RT. Temperature is also the same. And after what? 3P times 2V is new mass, and new mass is previous plus added, let it be X, over capital M RT. And notice that we need X. And you just consider simultaneous equations. That's definitely PV are all constants. To disappear, we should divide both sides. And we get what? 1 over 6 is what? 10 over 10 plus X. 10 plus X. 10 plus X is 60, so we can see that X is 50. 50 is C. Yes, it's correct. A mass is oscillating with simple harmonic motion at time t. The acceleration is at a positive maximum. What are the displacement and the velocity of the mass at time t? You may just consider an object on a spring, and if it's equilibrium position, and now it is at its maximum, positive maximum, and also it may be here, and let x-axis be to the right. And we know what is simple harmonic motion. It's what acceleration is directly proportional to the displacement and is in opposite direction to the displacement. And we need that what acceleration is at positive maximum. You can see that for this situation, you can see that displacement is negative to the left, hence acceleration is to the right. And if we choose x to be to the right, so acceleration is maximum at maximum displacement, and actually F is ma, so it's actually the same as restoring force. Acceleration is the same as restoring force. The difference is just a constant. And definitely this force and hence acceleration is always directed to the equilibrium point. And what is question? What are the displacement and velocity of the mass at time t? Definitely it stops at a point with maximum displacement, so v is 0, and maximum velocity is at equilibrium point, so v is 0, and displacement is negative because it's in opposite direction, so it's b, negative maximum displacement and 0 velocity. A standing wave is formed between two loudspeakers that emit sound waves of frequency f. Two loudspeakers, frequency f. A student walking between the two loudspeakers finds that the distance between two consecutive sound maxima is 1.5 meters. So standing wave looks like this, for example, and distance between two consecutive maxima, but in intensity, so it might be just maximum amplitude, not maximum of the wave. Sound maximum is 1.5 meters. The speed is 300 meters per second. And what we need frequency using formula which is given in a data booklet. Wave speed, it's what, frequency times lambda, so frequency it's what, c divided by lambda wavelength, so we need wavelengths, and we can see that 1.5 it's a half of wavelength, so lambda is 300, so it should be 100 hertz. 100 is c, what in c it's correct. 15. A pipe containing air is closed at one end and open and at the other, so it's open closed pipe. The third harmonic standing wave for this pipe has a frequency, third harmonic has frequency of 150 Hz. What are the frequencies possible for standing wave in this pipe? So you remember that the first harmonic looked like this, and we can see that some lengths, and if you don't remember formula, but it's useful to remember that possible frequencies for open pipe, and it will be the same as for string. Its possible frequencies is n v over 2l, and n it's any integer 1, 2, 3 and so on. And for open closed, f is n v but over 4l, but n is odd, 1, 3, 5. And notice that the third harmonic it's not the third possible frequency. It's not 4 and it's 5. By definition, harmonic, number of harmonic, is a ratio of given frequency to the fundamental, the first frequency. So the third harmonic, it's S3, it's 3V over 4L. And it's what? It's 150 Hertz. And you can see that we can calculate this. It's what? It's 50. So possible harmonics are just 50. F3 is 150. Then F5. It's what? It's 5 times 50, 250. Yes, and we can see the next options: 25, 50, 75 and 300. And you can see that 50 is possible, so answer is 50, it's B, 15, B. This formula can be easily deduced. You can see that it's a quarter wavelength, so 4L is lambda, and using again this, you can see that F is C over 4L, and it's fundamental frequency. And then if you draw the next possible harmonic, and notice that it's always node at the closed and antinode at the open and you may guess that you can see that it's 3/4 of L. Yes, yes, it's 3/4, and then you can deduce just from a picture lambda what it is. It's 3 over 4, and it's lambda is 4 over 3, and hence is the next possible harmonic. It becomes 3 C over 4L, and then 5, and so on. So general formula becomes like this. So you may just remember formulas. They are not given in a data booklet. 16. A longitudinal wave is traveling through a medium, so we understand that it's about sound. The variation with distance d of the displacement x of the particles in the medium at time t is shown, which point is at the center of compression. You should understand that particles are moving to the right, to the left, and what does it show us? It shows displacement of particles to the right or to the left. XD. How to understand it? If particle is usual, there are some particles, and if they are stationary, it looks like this. And you can see that now this particle is what? Displaced to the right, and it has such displacement. And this also displaced to the right, but its displacement is a bit smaller. So these particles are displaced to the right, and these particles are displaced to the left. And hence particles at A becomes a region of compression as required, so it's A. And you can see at C, to the left are displaced to the left, and to the right are displaced to the right, so it's a region of rarefaction. 17. A variable resistor is connected to a cell with EMF and internal resistance as shown. When the current in the circuit is I, the potential difference measured across the terminal of the cell is V. The resistance of the variable resistor is doubled. What is true about the current and the potential difference? So cell internal resistance, and we measure terminal voltage and variable resistor, and this resistance increases to 2R. Initially current is I and voltmeter shows V, and we need new current and new potential difference. So we know that terminal voltage, it's this V, it's what, EMF minus the potential drop across the internal resistance. And current, it's what, it's EMF divided by total resistance. It can be represented as total resistance around the circuit plus internal resistance. And for V, we need to say it becomes greater or equal. When R increases, it becomes 2R. Definitely this what? Denominator increases, this value decreases, so we subtract less, so V increases. So potential difference increases. And what about current? Current is just this, it decreases. So current less, V greater is B. No, just a moment. Oh, no, it's current decreases, it's correct, but options are greater than I over 2 or less than I over 2. So we should compare with I over 2. So initially current is EMF over R plus R, and it becomes EMF 2R plus R. And this new should be compared with I over 2. I over 2 becomes what? 2R plus 2 little r. And new becomes this. And you can see that for new current, denominator is what? Less, so it's greater. Yeah, so it's greater than I over 2. It's for current, and greater than V, so it's A. Two identical wires X and Y are connected with a switch to a cell of negligible internal resistance as shown. The electrons in wire Y have a drift speed V when the switch is open. The switch is closed. What is the drift speed of electrons in wire X? So wire X, initially it is opened, and wire Y, and initially drift speed is V in Y, and we need drift speed in X. Let it be X, something like that. Vx So, since it's about drift speed of electrons, we need a formula. And formula says that current is an area V Q. Q is charge of electrons, so electrons. It's the same. What about identical? Identical, it means same cross-sectional area and the same. This value, it depends on material, and charge is also the same. So we can see the drift speed is directly proportional to current. So we need to know how current changes. And let's consider current initially. Two identical wires, it means that they have the same resistance. So initially current is what? Some EMF divided by total resistance, and it's just R. But then current, let it be prime, becomes EMF divided by, and when switch is closed, the resultant resistance is 0.5 R, because in parallel you may use in general 1 over R is total is 1 over R plus 1 over R. You remember, if there are equal resistance in parallel, the resultant, to find the resultant resistance, you just divide resistance of 1 by number of resistors, and it becomes 2 EMF over R. So you can see that current increases by 2, hence V. No, just a moment. It's just current, but just a moment. Initially it's a current in a circuit, and since it was Y only, it was a current through Y. But now it's current in a circuit, so it's current before this parallel junction, and we know that in parallel what current adds up, so it will be split into two branches. But we can suggest that since wires are the same, this current will be divided by 2, so it will be just EMF over R at each branch. And we can see that if we consider X, current through X will be EMF over R, so it will be the same. So it will be also V. V is proportional to the current, but current must be through a given or considered resistor. And this formula, EMF over total resistance, it's current in the circuit, but initially there was only Y, so total current in the circuit also becomes current through Y. But now there are two resistors, and when we find current as EMF over total resistance in the circuit, we find current in the circuit. It means through the battery and up to this. But you can see that now there is parallel junction, and this current will be divided between them. But since they are equal, it's reasonable to suggest that current just divided by two equal parts, and this divided by 2, so you can see that now through X it's also the same value as it was for Y before, so V will be the same. 19. Three-point chargers plus Q and negative Q are fixed at the three corners of a square. What is the difference of the electric field at the fourth what is the direction of the electric field at the fourth corner. It's easy. Plus Q, negative Q, and the fourth corner. And we remember that electric field strength is what? From plus to minus. It's a vector, and the resultant electric field should be found as the sum of vectors. Parallelogram rule, something like a triangle rule. So field E, field strength E produced by this plus Q is from plus in this direction and of some length, and from plus due to this plus Q. But notice that length must be the same, because no, just a moment. We know what about magnitude. It's inversely proportional to the distance squared, and I don't know whether it's essential here that if the length is a, diagonal, it's what, a root 2. So this magnitude, it becomes what, kq over 2a squared, and this magnitude becomes kq over just a squared, and due to minus from plus to minus and of the same magnitude as this plus q, so kq over a squared. And we need direction, so the resultant vector of these two is using just parallelogram rule is this one. So instead of these two vectors, we can consider just one, and notice that over 2a, so it's should be 2 times shorter, like this. And if we find the resultant vector, definitely it's somewhere in this direction, so it's the resultant field strength is in this direction. And we can see options, and definitely it's not C, not D, not C, and A, it's too much close to horizontal, it's B. So 19B. 20. Two resistors of equal resistance R are connected with two cells of EMF E and 2E. Both cells have negligible internal resistance. What is the current in the resistor labeled X? So it is given the next. Cell X, another resistor, and they are equal, of equal resistance, and another cell here, E to E. Two resistors of equal resistance R, two cells, current in the resistor X, so let it be I1, and we can see what? We can see some complicated circuit and two cells at different places, so it seems we should use what? Kirchhoff's rules, and let current through this X be I1, and if we consider this junction, let's consider A, B, C, D, and let it be M, N. So if we consider point B, let current I1 be current through this branch and through X, and it's in B, hence let current I2 be here out and current I3 be here. And we know the total current in is equal to the total current out. And another, the second rule, says that the sum current times resistance is equal to the sum of EMFs. And let's consider A, B, C, D closed circuit. And let clockwise direction be positive. So sum of I, R. So let's move from A, so we can see I1, I1 is in clockwise, so it's positive, times R, next plus I3 times R, I3 is also in clockwise, so it's positive. There are no other resistors, so no other IR, is equal to the sum of EMFs. And notice that this EMF provides current also in clockwise direction, so it's positive, so it's E. And what do we need? Current in, so we need I1, we need I1. And now, and answer must be in terms E and R, so we can see that we should eliminate I2, and it means what? We need to consider another closed circuit. It doesn't matter, it may be A, M, and D, or B, M, and C, it doesn't matter, so let it be B, M, and C. And again, let clockwise direction be positive. Sum of IR. So we can see that there is what? I3, but in opposite direction, so it's minus I3R. And that's all is equal to just a moment. No, it's correct, yes, because it's parallel, so I2, I3 here, yeah, everything is correct. E is equal to, and you can see that this cell provides current in opposite direction, so it's minus 2E. And now we can consider it as simultaneous equations, and we can see that if we add both sides, we get just I1R is equal to what? Minus E. What does this minus mean? It means that actual direction of a current is opposite to our assumed direction. So find actually current through X is to the left, not to the right. But by magnitude it's E over R 20 C. It's correct. And you can see that it's not necessary here. But in general, you also need this to consider simultaneous equations of 3 equations. And the next question, 21. A negatively charged sphere is falling through a magnetic field north-south, north-south, so we know from north to south, so magnetic field strength vector is from left to right, negatively charged, minus directional motion falls down. What is the direction of the magnetic force acting on the sphere? And for what wire and proton are positively charged, I use left hand rule. For negatively charged particle, right hand rule. I use a bit different rule. So for all rules, if we consider a hand, this B vector must enter the palm, inner part of the hand. It doesn't matter right hand, left hand. And 4 fingers are in direction of current if we find force on the wire, and in direction of velocity if it's a particle. Here it's a particle, so 4 fingers in direction of V. So we take a right hand and put it so that this arrow enters the palm, 4 fingers down, and we can see that thumb at which is at 90-degree angle shows what? Into the page. So into the page. Force is into the page. Is D. And we remember that in general force is what? VB, QVB, and sine of the angle between V and B, and when V is parallel to B, force is equal to 0, or the thumb should be at 90-degree angle, and 4 fingers also. So 4 fingers, thumb, and B vector also must be perpendicular. And if you can put a hand according to a problem, you may suggest that force just is 0. But in general, you should understand for almost for all problems, V is perpendicular to B, so sine of 90 degrees is 1. But in general, you should understand that there is sine between V and B, and if it is given that particles is moving along a field, it means parallelly force doesn't act on a particle. And 22. An electron is accelerated from rest through a potential difference V. What is the maximum speed of the electron? It's quite easy question, because what energy gained by charged particle is charge times potential difference, and all energy gains is transformed into kinetic energy of the particle. And hence formulas are given. This formula is given in the data booklet. Maximum speed, so V is what? 2E capital H, potential difference, over M and square root. It's A. (23) A mass on the end of a string is rotating on a frictionless table in circular motion of radius r, and undergoes an angular displacement of theta in time t. So it's a circular motion, radius r 1 and displacement, it means in angle theta in time t. So angular speed is what? Theta over t. The string tension is kept constant, but the angular displacement of the mass is increased to 2 theta in time t. So angular speed or angular frequency should be increased by 2. The radius of the motion changes to R2, so we need new radius. And we know that what? Acceleration or force, net force, a centripetal force, and it is provided by what? Tension, but tension is constant, so acceleration of force is constant and is equal to omega squared times radius, and it's constant. So initially it's what? Theta squared over t squared times r1, and it should be the same as 2 theta squared over t squared times r2. And we can see that r2 must be what? r1 over 4. 2 squared, 4, and move to the left. So it's a. A nucleus of platinum undergoes alpha decay to form an osmium nucleus as represented by the following reaction. 78, 175. Osmium plus alpha particle. It's not given, but we know that it's what? 2, 4. What are the number of protons and the number of neutrons in the osmium nucleus? So this value just equates 78, it's x plus 2, so 76, and it's what? 171. But notice that it's a proton number, so number of protons, and we need number of protons, it's number of protons, it's 76, but this mass number, it's number of the neutrons and protons or nucleons together, it's 171. So 171 minus 76, it's what? 595. And 24, 76, 95 is the 95 and 76 is the, yeah. So 25. A car engine has a useful power output 20 kilowatts and an efficiency of 50% to 0.5. The engine consumes 1 times 10 to negative 5 meter cubed of fuel every second. What is the energy density of the fuel? Energy density, or you can see options, it's what? Energy divided by meter cubed, so it's energy divided by volume, and it becomes energy density. So we need energy divided by volume. Volume is given, It's 1 times 10 to negative 5 meter cube. So we need energy. And what is efficiency? Efficiency, it's useful, it's 20 kilowatts, since we consider for every second, or we consider time to be 1 second, it becomes energy 20 kilojoules, and divided by total energy input, and it will be energy provided by the fuel, and we need this. So we can see that 0.5, it's what? It's a half, so energy it's 40,000. So it becomes 4 zeros and 5, it's 4 times 10 to the power of 9 joules per meter cubed, and to the power of 9 it's giga, so it's 4 gigajoules per meter cubed. It's D, 25, D, correct. 26. The gravitational field strength at the surface of the Earth is often taken to be 9.8 newtons per kilogram. The use of this value to calculate the weight of an object above the surface of the Earth is definitely G. Formula is given. It's what? Constant mass of a planet and distance from the center of a planet. So it's radius of the Earth plus height above the surface. So at the surface it's 9.8, and definitely somewhere above it decreases. But let's consider options. So again, the use of this value, what value? 9.8, to calculate the weight above the surface. It means that we use this value, which is actually greater value. Actual value will be less. So if you calculate somewhere above, it's definitely it's not noticeable difference, but in fact it will be overestimated in general. So to use this 9.8 above the surface of the Earth is option A, a paradigm shift in our understanding of gravity. No, definitely not. It's assumption, not prediction. Paradigm shift. An attempt to model gravitational field. No. See, an outcome from a peer review. Definitely something. D, something not what we need. D, an approximation used for estimation purposes. Definitely D is correct. It's approximation. We assume that it's constant because it changes slightly. Yes, it's D. (27). A student measures the count rate of a radioactive sample with time in a laboratory. The background count in the laboratory is 30. So background is 30 counts per second. Count rate, counts per second, 150 at T0 and 90 at 20. What is the time at which the student measures the count rate of 45 counts per second? So background is 30. What is the time at which student measures the count rate of 45? Yes, So we should understand that we should consider count rate corrected count rate if he measures 150 directly from a sample. It's 120, then what it becomes 60 minus, and you can see that it decreases by factor of 2, so it's a half-life. Half-life it's 20 seconds. And if he measures 45 minus 30, it's 15. So one additional half-life, it will be 30, and then again then 50. So it's one half-life, it's 20 seconds, 20 seconds to get 30, and then plus 20 to get 15, or 1, 2, 3 half-lives. So it's 60 seconds. 27C, correct. 28. The following reaction is proposed for the collision of a proton P and a neutron N. So proton plus neutron, proton plus pi 0. Without any question, we can see that what baryon number is not conserved. The neutral pion pi 0 consists of an up quark and anti-up. Anti-up. Which conservation law does this equation violate? Definitely, it doesn't matter the construction of pion, because it's clear that baryon number is not conserved, because protons and neutrons are baryons. Pion is meson. 29. Wind generator X has a maximum power output Px for a particular wind speed. For the same wind speed, wind generator Y has a maximum power output Py. The blade radius of Y is 3 times the blade radius of X, so it's R3R. And Y is twice as efficient as X. So if it's efficiency, it's E, it's 2E, 2 times larger. What is Px over, Py over Px. And what is P again? It's maximum power output. So since it's about wind generator, we should use the formula. It is given in a data booklet, and it says that maximum possible power output, it's a half cross-sectional area, which is pi radius squared, and the density of the air is the same, and wind speed cubed. So it seems that with wind speed is the same, rho is the same. Yes, so maximum possible power output for Y. For Y it's proportional to 3R squared, it's just R squared. But X can extract one part or something, but Y can extract 2 times larger amount of energy, and we can see that Py over Px or Py is what 18 times larger, and it's D. And finally 30. A planet has an albedo of 0.3, and notice that it's planet altogether, not just the surface. Incoming intensity, it's 100 watts per meter squared, and what reflected and radiated and coming back, it's 60. So a simplified energy balance for the planet is shown. What is the intensity radiated by the surface of the planet, and surface it is assumed to be a black body, so all energy received is then radiated, and since incoming intensity is 100 and albedo of a planet is 0.3, so 0.7 is absorbed, so it means 70 is absorbed and then radiated. It's 70, this 70 radiated, but it's definitely due to what greenhouse effect. 60 is coming back, and it will be also what absorbed, and then 100 also will be radiated. So finally 130 watts per meter cubed is radiated by the surface of the planet. So it's D, and that's all for this paper.